So today we're going to learn about molecular orbital theory. So the molecular orbital theory explains how molecules behave after formation. So ano ba yung mga ini-explain ng molecular orbital theory? So the following. So we have the bond order, the bond length, the diamagnetic and the paramagnetic effect, and the stability of the molecules. So in explaining the molecular orbital theory, we are going to consider the molecular orbitals of molecules composed of two identical atoms, also known as homonuclear diatomic molecules. So but before we proceed with the MOT or the diagram for the molecular orbital theory, let us have the main points of the MOT. So what are the main points? First one is the atomic orbitals combine to form new orbitals known as molecular orbital. So for example, meron tayong hydrogen atom. So for each of the hydrogen atom, we have the atomic orbital. Okay, so this is the shape of the S orbital. It is spherical in shape. So we have two atomic orbitals for the hydrogen atom. If we combine the two atomic orbitals of hydrogen atom, we will form what we call the molecular orbital. So this is now the molecular orbital for the hydrogen molecule. So we have the MO. When we combine atomic orbitals, molecular orbitals are formed. The second point is the number of molecular orbitals formed are equal to the number of atomic orbitals combined. So when two atomic orbitals overlap or they are combined, they form two molecular orbitals also. So if you're going to combine or there are 6 atomic orbitals overlapped, it will form also 6 molecular orbitals. The third point is when atomic orbitals overlap, they form two types of molecular orbitals, the bonding molecular orbital and the anti-bonding molecular orbital. So if one atomic orbital is combined to the other atomic orbital, or if these two atomic orbitals overlap, they form two molecular orbitals. So this atomic orbital is the bonding molecular orbital, and the other molecular orbital is the anti-bonding molecular orbital. Next is the BMO or the bonding molecular orbital has lower energy than the anti-bonding molecular orbital. So the BMO or the bonding molecular orbital has lower energy than the anti-bonding molecular orbital. So according to the Aufbau principle and the Hans rule, if you're going to put the electrons in the molecular or in the orbitals, we always put it first with the one in the lower energy, and then we proceed to the higher energy. So in this case, electrons are filled up in the BMO first, followed by the ABMO, because BMO has lower energy than the ABMO. The fifth one is that the axial overlapping forms sigma bond, while parallel overlapping form the pi bond. So let us review the shape of the S and the P orbital that we have discussed last time. So ang S orbital natin is always spherical in shape, while the P orbitals are dumbbell in shape in 3 orientation, the X, the Z, and in the Y axis. So when two S orbitals overlap, they form an axial overlapping or a head-to-head overlapping. So when two S orbitals overlap, they form sigma bond or the head-to-head overlapping. Okay, so this is true for the S orbital. So it always form a sigma bond. While on the P orbital, since we have 3 orientations, the X, Y, and the Z, we are going to form one sigma bond because we'll be having a head-to-head overlapping. So this one is a sigma bond. We also have two pi bonds because the other two are in the parallel overlapping or the parallel orientation. So these are the two pi bonds. Okay. So again, for the s orbital, we have the sigma bond, while for the p orbitals, we have one sigma bond and two pi bonds. These two sigma bonds are axial overlapping, while these two pi bonds are parallel overlapping. Lastly, BMOs are represented by the sigma and pi, while ABMOs are represented by the sigma star and pi star. Those are the main points of the molecular orbital theory. This time, we're going to draw the molecular orbital diagram. As we have said earlier in the main points of the molecular orbital theory, the sigma or the bonding molecular orbital, the BMO, has lower energy than the ABMO or the antibonding molecular orbital. So if you have electrons in the atomic orbitals of both atoms, the BMO will be filled out first or filled up first, followed by the ABMO. So the BMO here for the s orbital is sigma, and the antibonding molecular orbital is sigma, represented by the sigma star 1s. So for example, we have the hydrogen atoms. We have two hydrogen atoms forming the hydrogen molecule or H2. So for each orbital or for each 1s orbital of hydrogen atom, it has one electron. So after overlapping, yung dalawang electrons will go first to the BMO or the bonding molecular orbital because BMO has lower energy compared to the ABMO. These two electrons from the 1s orbital will go to the BMO or the bonding molecular orbital. So again, the number of orbitals must be conserved. So when two atomic orbitals come together to form the molecular orbitals, they will form one bonding orbital and one antibonding molecular orbital. So ano yung meron sa bonding and antibonding molecular orbitals? So the bonding molecular orbital stabilizes the molecule while the antibonding orbitals decreases the stability of the molecule. This means that if you have a complete number of electrons on all the ABMO and the BMO, or an equal number of electrons for the BMO and the ABMO, no bonds will be formed. Again, if we have equal number of electrons in the BMO and the ABMO, no bonds will be formed. And if the number of electrons in the BMO is greater than the number of electrons in the ABMO, bonds will form. The stability of a covalent bond is related to its bond order. So how do we compute for the bond order? So to compute for the bond order of a molecule, we need to subtract the bonding electrons to the anti-bonding electrons in the molecular orbitals and divide it by 2. So these are the possible values for the bond order. So for the bond order 0, we will be expecting that there will be no bonds formed between the molecule or between the atoms. If you have a bond order of 1, there is a single bond between the atoms. A bond order of 2 would mean there is a double bond, and the bond order of 3 would mean there is a triple bond between the atoms. Bond orders 0.5, 1.5, and 2.5 are also possible. And then the stability is directly proportional to bond order. So let's go back to the molecular orbital diagram of hydrogen. So from the two 1s orbitals, we combine these orbitals, forming now the two molecular orbitals in the center. So ito yung dalawa nating molecular orbitals. So these two electrons will go first to the BMO. Lagyan ulit natin. Lagi mag-start with the BMO. Kapag puno na yung orbitals ng BMO, yung sobrang electron pupunta ngayon sa ABMO. But since we only have 2 electrons, so those 2 electrons will go to the BMO first. So for the bond order of hydrogen molecules, we have 2 electrons in the BMO. So you just write 2. We don't have any electrons in the ABMO, so minus 0. Then divide this by 2. 1. Ayan. Okay. So we have the bond order 1. So this means that there is a single bond between these two hydrogen atoms. Tama, di ba? We have one bond between these two atoms. We have a single bond between the hydrogen atoms. Let's try it with the helium molecule or the He2 molecule. So for the helium molecule, we have 2 electrons in the 1s orbital, di ba? Yan, 2 electrons. So we'll start filling up the BMO sa baba with 2 electrons. And then the rest will be on the ABMO. Computing for the bonding molecular or the bond order, we have 2 electrons in the BMO minus 2 electrons in the anti-bonding molecular orbital divided by 2. The answer is
0.
0. All right. So we have a 0 bond order. This means that a bond will not form between the 2 helium atom and is unstable. Okay? So with this, with the help of the molecular orbital theory, malalaman natin na hindi talaga pwedeng magkaroon ng helium molecule or He2 molecule or diatomic molecule ni helium because the bond order here is 0. Okay? It will not be stable and there will be no bonds or bond formed between the 2 helium atoms. Let's take a look at the p orbitals. So for the p orbitals, for example, you have a 2p orbital or 2p orbitals. So for the p orbitals, sabi natin kanina, we have 1 sigma bond and there are 2 pi bonds. Okay? Dalawang pi bonds. So this means that we have a 1 sigma bonding orbital or 1 sigma BMO and 2 pi BMOs. And then for the anti-bonding, we have 2 pi star anti-BMO and 1 sigma star. So these are the arrangements of their orbitals. So the lowest energy is the sigma BMO followed by the pi BMO. Then the pi star and the sigma star have higher energy than the sigma and the pi BMOs. So according to the study of the scientists, they found out that this orientation of or arrangement of molecular orbitals is true for the oxygen and the fluorine molecules. For the elements of hydrogen to nitrogen, nagkakaroon ng shift ng arrangement nila. So mas bumababa yung energy ni pi tapos tumataas yung energy ni sigma. So this is for, again, the hydrogen to the nitrogen atom. Let's have an example. So for example, we have oxygen. So oxygen is 1s2, 2s2, 2p4. 4, 5, 6, 7, 8. Ayan, 8. 1, 2, 3, 4. So 1, 2, 3, 4. For the P, we have 1, 2, 3, 4. 1, 2, 3, 4. Okay. So a total of 1, 2, 3, 4, 5, 6, 8 electrons. 1, 2, 3, 4, 5, 6, 7, 8. Ayan. For the band order, ganun ulit. So we have 2, 4, 6, 8 for the bonding BMO minus 2, 3, 4 minus 4 for the ABMOs. So divided by 2. The answer is 2. Okay. Okay, so the bond order is 2. Mayroon siyang double bond. And it is still a paramagnetic pa rin. Paramagnetic substance talaga siya kasi meron tayong dalawang unpaired electrons dito. N2. N2 is 7. So 1s2, 2s2, 2p3. 3, 4, 5, 6, 7. Okay. Sa 2s, filled up the orbitals, the BMO first, followed by the ABMO. And then 2p3, meron tayong tatlo. Okay. So we're going to fill up first the pi, 2p orbitals here with 1, 2, 3, 4, followed by the sigma, 5, 6. Okay. So total of 6 electrons. Bond order. So there are 2 and 6. There are 8 electrons. For the anti-bonding, we have 2, tapos none here, so minus 2, divided by 2. What is the bond order?
3 po, sir.
3. Okay, so there will be a triple bond. Ayan. May triple bond siya kasi ang bond order niya ay 3. Is this para or dia?
Diamagnetic siya.
Okay, so nitrogen is a diamagnetic substance. If we're going to look at the individual atom, masasabi natin na siya ay para kasi meron siyang unpaired electrons. But using molecular orbital diagram, we see that there are no unpaired electrons. So therefore, nitrogen molecule is a diamagnetic substance. Next, let us now compare the bond order, stability, and magnetic nature of N2, N2 negative, and N2 positive. So kanina, pinakita natin sa N2, di ba? Ang kanyang electron configuration is 1s2, 2s2, and 2p3. So isulat ulit natin yung kanilang electrons. We have 3 here. Okay. And then 1, 2. All right. So this is for the N2. So the bond order of N2 is 3. For N2 negative, this means that meron tayong additional 2 electrons to the nitrogen molecule or the N2 molecule. So if we going to add 2 more electrons, so meron tayong 1, 2 electrons dito. So what is the bond order for the N2 negative? Anong bond order natin pag N2 negative? Meron tayong 2, tapos meron tayong 2, 4, 6, so a total of 8. Minus, sa ating ABMO, we have 2. And then we also have 2 here. 8 minus 4 divided by 2, the answer is?
2.
2 po.
2. Okay, the bond order of N2 negative is 2. How about for N2 positive?
Sir, mababawasan po isa.
So we're going to remove 1 electron here. So after removing 1 electron, so what will be the bond order for N2 positive? So we have 2, 3, 4, 5, 6, 7. So there are 7 electrons in the BMOs. Okay. For the ABMO, we only have 2. So 7 minus 2 divided by 2. What's the bond order?
2.5.
2.5. The bond order of the following are 3 for N2, 2 for N2 negative, and 2.5 for N2 positive. So if we're going to arrange this according to increasing bond order, sino yung mauuna?
Una po yung N2 negative, then N2 positive, then N2.
So N2 followed by N2 positive and then yung pinakamalaki ay ayan din na. N2. Okay. This is according to increasing bond order. So this means that the most stable of the three is N2. The least stable is N2 to negative. Stability is directly proportional to bond order. So the higher the bond order, the more stable the molecule is. Okay? How about the magnetic effect of the molecules? Let's start with N2. Is this para or dia?
Daya po, sir.
Dia. Dia C, N2. How about N2 to negative? Para or dia?
Para po.
Para magnetic. N2 positive.
Para po, sir.
Para magnetic. Okay, let's have another set of examples. Okay, so we have O2, O2 negative, O2 positive, and O2 to negative. So again, we have O2, O2 negative, O2 positive, and O2 to negative. So let's start with O2. So we have 2 dito, 1, 2, 1, 2. So wala namang magbabago sa s orbital. So sa pilan tayo magkakaroon ng pagbabago. So for the O2, okay, O2 natin. So we have 1, 2, 3, 4, 5, 6, 7, 8. Okay, so this is for O2. Ano ang ating band order again for O2?
Po.
2. Okay. Next, yung ating paramagnetic or diamagnetic effect. Is O2 para or dia? Is this para or dia?
Para magnetic po, sir. Para magnetic.
Okay, para magnetic because of the two unpaired electrons. Okay. Next, how about for the O2 negative? Ilan ang idadagdag ko na electron?
Isa po, sir.
Okay, we're going to add 1 electron. So, hindi tayo maglalagay dito ha. Kasi ibang level yan eh. Mataas na level yung ating sigma star ABMO dito. So, dapat dito tayo susunod na maglalagay. Hindi pwede doon ha. Yung same level lang ng energy dito. Okay. So, ngayon, meron tayong isang additional electron dito. So, what is the bond order for O2 negative?
1.5 po.
1.5. Okay, so we have a 1.5 bond order. Is this para or dia?
Para po, sir.
Okay, para. Next, how about for O2 positive? So, tanggalin na natin to. Magdadagdag, magbabawas.
Babawas po, sir.
Magbabawas
Okay,
po,
we're
sir.
going, ilan?
Isa po.
Isa po.
Isa. So, tanggalin natin yung isa. Dito. Ayan. So, what is the bond order now? For O2 positive. What is the bond order? 2.5. Is this para or dia?
Para pa din po, sir.
Para pa rin. So, para magnetic. Next, for O2 to negative. Ito, magdadagdag tayo ng
Dalawa.
ilan? Dalawa.
Dalawa.
Okay, so 1, 2. Okay. Next, bond order.
1 po, sir. 1.
1.
1. So, the bond order is 1. Now, the magnetic effect.
Daya po, sir.
Dia.
Diamagnetic.
Okay, so this is diamagnetic. Wala tayong unpaired electron. So, diamagnetic. Next, according to stability, sinong mauuna?
Si 0 to, ano po, 0 to negative.
Ano 0, 2?
Ay, auto po, auto.
Okay, O2. O2 to negative, followed by
Ano po, O2 negative.
O2 negative, followed by
O2 po, sir. O2.
O2, and then the most stable.
O2 positive po.
Gawan nyo to ha. H2 positive at saka H2 negative. Ayan. So alamin nyo kung ano ang bond order ng bawat isa, ang stability. Pag sabing stability, yung arrangement nila ha, kung sino mauna. Tapos magnetic nature. Busy ka naman eh. Ayan.
Ganyan po, sir.
Okay, so that is for H2. Next, for H2 positive naman. H2 positive. So this one is for H2. Next, who would like to try for H2 positive? Ay, tanggalin mo na isa dito sa kabilang side kasi isa lang naman eh. Tanggalin mo na to. Okay. Ayan. How about for H2 negative?
Dalawa po sa baba. Tapos
Teka lang.
po, dalawa din pa. Sige po.
Sige lang. Dalawa sa baba.
Tapos, dalawa po dun sa upper left po.
Up.
Ay,
Ito?
pwede po. Apo, sir.
Dalawa yan. Tapos isa dito.
Apo, sir.
Tapos isa dito.
Ay,
May isa ba dito?
wala po, sir.
Bakit wala?
Ay, one. Sir, isa lang po yung madadagdag, sir, di ba?
Isa yung madadagdag. Dalawa na to, di ba?
Opo, sir. Tapos
Saan mo lalagay yung
nagdagdag
isa?
po. Ay, sa taas po ba dapat?
Ayan. Dito sa isa. Dito.
Sir, bali po, isa na lang po yung nasa left po, sir.
Tama yan na dalawa. Tama siya na dalawa.
Ay, tama.
Kasi nagdagdag tayo ng isang electron, di ba? We added one electron. Dito, we subtracted one electron. So it's either matanggal yung isa sa left or isa sa right. Yung kanina kasi yung ginawa ko, balik tayo doon. Dito. So hindi ko na pinakita. Yung ginawa lang natin is dinagdagdag at nagbawas lang tayo from the original molecular orbital. Okay? So dito, sa pangalawa, ayan. So dito pinakita na natin kung saan tayo nagdagdag at nagbawas ng electrons from the original atomic orbital. Okay?
Okay po. Thank you po.
Okay, thank you. So, band order naman. Anong band order ni H2?
1 po, sir.
1, 1. Okay, 1. Clear. Next, H2 positive.
0.5 po.
0.5. Next, for the H2 negative.
0.5 po.
Alright, so arrangement natin, stability, sinong mauna? Okay, so H2 positive tsaka H2 negative, they have the same bond order, 0.5, di ba? Pero si H2, 1 siya. So ito yung most stable sa lahat. Lagyan natin dito. Yan, most stable. Dito, hindi natin pwedeng sabihin na equal sila. Okay, kasi magkaiba pa rin sila ng kanilang molecular orbital diagram. Okay? So, although para sila ng bond order, meron pa rin sa kanilang dalawa ang mas mataas ang stability. Paano malalaman? Let's look at their orbital diagram, the molecular orbital diagram. Okay, i-compare natin. So, from these two, meron tayong dalawang electron sa ating sa ating BMO. Dito isa, merong electron dito. Dito, meron tayong isang electron sa ABMO. Dito, walang electron sa ating ABMO. Sabi natin kanina sa definition ng BMO tsaka ABMO, yung ating bonding molecular orbitals stabilizes the molecule, while the ABMO or the anti-bonding molecular orbital decreases the stabilization or decreases the stability of the molecule. So if you have one electron in the ABMO compared to there is no electron in the ABMO for H2 positive, which will be more stable, the H2 negative or the H2 positive? H2 positive is more stable than H2 negative. Why? Because here, meron tayong isang electron sa ABMO. Dito, walang electron tayo sa ABMO. This means that no electrons in the ABMO increases the stability of the molecule compared to the one with an electron or there are electrons in the ABMO. Kasi ito, ang ginagawa nito ng ABMO, binabawasan yung stability ng ating molecule. Kung wala kang electron sa ating ABMO, mas stable siya compared doon sa merong electron sa ating ABMO. So, gagawin mo lang yung comparison kapag pareho sila ng bond order. So, according to stability, H2 is the most stable, followed by H2 positive and the H2 negative. Okay? How about the magnetic nature? H2 is
Daya po, sir.
H2 positive
Para po, sir.
and H2 negative.
Para